Hey, welcome back to Getting Started with Web Development. That's Michael Troy, and I'm Christopher Harrison. In the first module, what we did was, well, I guess what I did, since I did most of the talking there, is I sat here and I read a handful of slides that had a whole bunch of technical terms on them, and there's a very good chance that you probably listened to that, you read the slides, and you went, okay, I really don't know what any of that meant. Well, that's okay. That's actually why we have Michael here. What Michael's going to do is he's going to start to talk about what all of those different things mean and how they fit into the bigger picture by taking a look at a neat little analogy. It's actually one that I really enjoy, and hopefully try to clarify what all of those various terminologies, technologies, and moving parts are going to do and how a web application works. So, Michael, how does a web application work?
Sure. So the analogy that seems to really help people understand how web applications works at a high level is by thinking of this analogy. And this analogy I've used a few times, and it seems to really help a lot of people understand how all the different pieces work together to make a web applications work. So here in the slide, we have a picture of this one particular furniture store. And the way that this furniture store works is, let's say that in this furniture store, which is represented by the blue box, we have 3 lines of customers who are waiting outside the store. And people are lined up, waiting to get into the store. Now, what exactly happens in this furniture store is composed of 3 distinct parts. In the furniture store, the first layer is the receptionist. Now, in this example, in this store, we have 3 receptionists who is responsible for waiting for the customers to come in with a particular order about what the customer wants, and the receptionist then hands off that order to these workers. And here in this example, we have 4 workers whose responsibility is to take the order form from the receptionist and then take it to, a lot of cases, to the warehouse. And you can imagine that the warehouse would have a lot of cabinets with different parts of the furniture store. They may have some desk parts, different parts of what makes the desk, the table leg, different parts of the chair, all organized neatly in multiple cabinets. So imagine that a typical order comes in, a receptionist handles that order, gives it to the worker has certain instructions about how to fulfill that order, walks over to the warehouse. The warehouse may have some other workers going and retrieving different parts. They hand off the parts to the workers who may do some work to assemble, who hands it off to the receptionist, and the receptionist hands off the assembled furniture back to the customer. Now, we can make this story a little bit more interesting. Now, imagine in the store that I have workers who, let's say, speak English. Now, what's interesting is, let's say that in this example, English speakers, let's say, come with certain toolboxes that allow them to assemble furnitures maybe a little bit more efficiently, maybe certain aspects of assembling the furnitures. So you can kind of imagine that in one particular furniture store, I may have English workers who assemble furnitures together, and they may have their own toolboxes that they use to assemble furnitures. And in maybe another store, you could also have Spanish workers or Korean workers or Chinese workers who come with their own sets of toolboxes that are a little bit unique. And so kind of imagine that. You can also imagine that when it comes to the warehouse, if I asked you to go and design that warehouse and display or organize different parts in the furniture store, you can probably come up with maybe hundreds of different ways to organize different parts, right? So the example, this analogy, the way that it works in terms of the web application is that the receptionist represents the web server. And the web server, within the server, is the first kind of program or the agent that handles what the customer wants. Now, what is actually the customer that were waiting in front of the furniture store? Those were actually actual people who typed in, for example, Microsoft.com or CodingDojo.com into the browser, which triggers a request, and it sits and it waits for the server to respond. So the receptionist or the web server is the first program or the agent that handles that. Now, once the receptionist or the web server handles that request and receives that request, they hand it off to the workers. And just like in that furniture store, where you could have English workers, Spanish workers, Korean workers, or different workers, here in web application is also exactly the same. I could have PHP assemble the furnitures together. I could have Ruby assemble that furnitures together. I can have C#, Java, or different programming languages to carry out that instruction. But what is really important is that regardless of what languages these workers speak, ultimately what the worker's job is to assemble the furnitures together. And what programmers do is basically create the instructions for the workers to follow. So for example, the programmers say, first, when you get this particular request, one, go to the warehouse, ask for these parts, then put this part with this part, and then after you do all of that, hand it off to the receptionist. That's basically what web programmers do. They create that instructions for the workers. Now, whether the web programmers create that instructions in Ruby, PHP, C#, or Java, frankly, it doesn't really matter that much because at the end, what the customers walk out is the finished product. In this case, what is the finished product is the HTML, CSS, and JavaScript. HTML usually contains the information that's necessary for the web application to be displayed. The CSS dictates where that information should be displayed. And the JavaScript is basically the instructions for the browser to handle interactions. So for example, when the user clicks on certain event, maybe tell the browser to move certain things or to show certain things. That's basically what JavaScript is. And at the end, regardless of what languages are used by the web application, at the end, all of the web applications produce HTML and CSS and JavaScript at the end. Now, what are these toolboxes? Remember that in the furniture store example, we talked about how different languages or different workers bring their own sets of toolboxes. So for example, PHP may have certain libraries or toolboxes that are unique for a certain operation. We can pick the example of Python. Python was a language design and is very friendly for beginners and also very popular among scientists and mathematicians. And therefore, it has a lot of these libraries that makes math computation very, very easy. So instead of the programmer creating those instructions separately, there are these toolboxes that Python developers can use that make a lot of those data analytics and maybe even machine learning a lot easier. So it comes with certain toolboxes. We can also argue in this example that frameworks are toolboxes that are available for different languages. So for example, PHP would have their own different frameworks that you can use, such as CodingNighter, Zend, CakePHP, Symfony. Within C#.network, there are also different frameworks that could be used to help these workers be more organized. Node.js also has their own framework to make things a little bit easier. Now, one concept that I'll bring over here is the concept of MVC. And we put it over here for C#.net. For C#, ASP.NET has a great MVC framework you can use, but almost all languages have their MVC framework. Now, what does that mean? And I want to address that a little bit because later on, we'll be talking about MVC a little bit more. So imagine that among these workers, what we have decided to do is to split the workers into 3 different groups. So imagine that this one group, we're going to call them the views. And what they're going to do is they're going to handle the creation of the HTML, CSS, and JavaScript. That's what the team is supposed to do. Let's say the middle ground, the middle team over here, let's call them the controllers. And the controller's job is to mainly coordinate between the receptionist and between these 2 teams, the views team and the models team. The models team basically take care of the instructions necessary to talk to the database and to process that information. So again, in review, these middle, we can call them the controllers, views, and models. Or in other words, models, views, and controllers. And that's what that MVC framework stands for. that MVC basically just means that the workers, we're going to split them into 3 different groups. One that handles the database component, one that generates the HTML and CSS and JavaScript, and one that basically coordinates the details. Now, why is that done? It's quite simple. And the reason is that when the instructions become very complicated and when it becomes very big, it can be kind of chaotic. Imagine that if you have all of those instructions in a single file, and imagine that you have hundreds or thousands of programmers working on creating this unified instructions for all the workers. If you have a very complicated operation, that could be very overwhelming for all the developers to collaborate. And this is why you kind of group them into different groups, which is basically the purpose of object-oriented programming. And in this particular case, we're going to split them into 3 different teams. It allows the code to scale a lot better. It allows us that when the code becomes a lot more complicated, we can throw multiple developers and we can kind of assign them different roles. We can say, well, for this one aspect related to handling email, why don't you handle the model component? Or why don't you handle the view component and so forth? And MVC framework has kind of become the standard way of building web application. Now, in this slide over here, we put a lot more terminologies.
A lot more terminology.
Yeah, absolutely. So over here, we kind of showed how some of the other languages or technologies that we described fit into this picture. So you can see that, yes, at the end, what customers walk out is HTML, CSS, and JavaScript, but also there are some other tools that are available to make creation of HTML and CSS and JavaScript a little bit easier and a little bit more concise. And that's where Haml comes in. Haml is basically a tool for developers to use to generate HTML, but in a kind of a more concise way. Less than Sass is basically that, but doing that for the CSS component. And CoffeeScript and TypeScript are tools that make it that basically generate JavaScript codes for the browser to render. Now, developers can just write plain HTML, plain CSS, plain JavaScript, and that will be okay. But using these tools sometimes help the developers to keep their codes more concise, and that is an added benefit. Now, there are some other JavaScript frameworks that are available as well. Now, what has happened lately is that a lot of our web application has really become more complicated and more complex over the years. So especially over the last few years, the web applications that's being served is doing a lot more JavaScript than ever before. So before, when the programmer just needed to send maybe 10 or 20 lines of instructions for the browser to handle, now imagine that you want to create something like Microsoft PowerPoint, but you want to do that on a web as a single page. You can imagine how many interactions the browser would need to handle to do all of those tasks. So what's happening lately is that there are a lot more frameworks that are popping up to help the developers organize their JavaScripts a little bit better. So you can see in this slide that we have jQuery, which is a very light JavaScript library that you can use to allow multiple browsers for different browsers to perform some of those interactions. But it's not enough yet, especially if you're wanting to build something that's more complicated. And therefore, there are other frameworks such as Angular, Ember, React, Backbone, Knockout, and basically
the list keeps going.
It keeps going on and on. And quite frankly, it's easy for someone who's a good JavaScript developer to go and create their own framework. Mm-hmm. Now, all these different frameworks have their own different philosophies about how things should be done. And that's basically why there are so many different kind of frameworks, JavaScript frameworks. But at the end, it's important to remember that all these JavaScript frameworks are there to make it easier for the developers who are putting all those complex JavaScript instructions to organize their codes and to work more efficiently. So for example, instead of throwing 1 million lines of code for the browser to handle, and it could be overwhelming if you have multiple JavaScript developers working on it, instead, these frameworks allows you to organize your codes in different buckets. And even within these JavaScript frameworks, there are MVC or MTB frameworks that you can use, that's basically how it works. Now, within web servers, there are different web servers that are available depending on different technologies. For different languages, there are different frameworks that are available for you to use. And of course, when it comes to database, there are many different types of database. One common thing that we get asked sometimes while teaching Coding Dojo student has been, if you go with one particular language, let's say a backend language, say Ruby or Python, does that mean you have to go with a particular database or particular places where you have to host these servers? And the answer is most often, it doesn't really matter. It's very independent. It's modularized. So even if you're using PHP, Ruby, or Python, you can use different types of databases as well. Now, when it comes to web server, that's a little bit different. Usually, web servers are more optimized to work with one particular language, but not all the time either. Okay. Now, one last thing that I have in the slide is also there are different places that you can host this server. You can do it within Microsoft. You can do it in Amazon, AWS, Rackspace. There are Heroku, GoDaddy, Bluehost. We won't really go into detail of this. Maybe later in some of the other modules we'll go into that. But the important piece is that at the end, all of these web applications is to create HTML and CSS and JavaScript for the browser to render. Whether I use PHP, Ruby, Python, C#, at the end, it's all HTML, CSS, and JavaScript. Now, I can store that data in different places. It doesn't really matter. But maybe one last thought that I would add that's covered in the slide is sometimes what's confusing is when you hear some of the terms such as front-end, back-end, client-side, server-side. What does that really mean? So what front-end means is basically what the browser sees, HTML, CSS, and JavaScript. And developers who work on that component is called front-end developer. Now, back-end or back-end developers focus on what happens within the server, writing instructions for the workers and kind of designing the database and so forth. So that's what back-end means. Client-end basically means what happens by the browser most of the time. And server-side basically means all of these operations that happens within the server.
Beautiful. So that's, I think, a fantastic explanation of where all of those various moving parts are. In the next section, what we want to do is dig a little bit deeper into some of the more common frameworks and start to explore why you might decide to choose one over another. So we'll do that in the next module.